All right, you guys, video two. This one's going to be over fossil fuels, not including, so non-renewable resources, not including nuclear. So just a really fast review. We get fossil fuels from the different layers of the Earth. So that's why we're going to review this. So the asthenosphere, so let me start at the beginning. We have the inner core, we have the outer core. These are made out of iron. And then we have the mantle. And then on top of the mantle sits the upper mantle. And then the upper mantle is kind of like a molten plastic, and so the crust sits on top of that upper mantle, and so that's the outermost layer. We can talk about the asthenosphere. The asthenosphere is the upper part of the mantle and the lower part of the crust. And the asthenosphere is kind of molten. Like I said, if you think about like really molten but thick, but still kind of liquidy plastic, that's what the asthenosphere is made out of. So it is liquid. It does have, remember, those convection cells that come up, it's going to heat up, rise, and it's going to cool back down. And then on top of the asthenosphere floats the lithosphere. And the lithosphere is the crust, like the land of the earth, and that's where we find fossil fuels. So just as a general reminder, fossil fuels are deposits in the Earth's crust. They're composed of remnants of fossils from a long time ago. And when we're talking about fossil fuels, we're talking about coal, oil, and natural gas. They currently supply about 80% of the energy used in North America, and they are not replenishing on a time scale appropriate for humans. So it will take millions of more years to get them back, and that's not really realistic if we need energy, say, in 25 years. So fossil fuels formed about 300 million years ago, and it had to do with the climate. It was a lot cooler. There were swamps everywhere. And so if the dead decomposing plant material decomposed over land, then that formed coal. If it decomposed over the water, then that's oil and natural gas. But either one, what we want to think about is that there is dead decomposing plant material and fossils. That's why you can, somebody wants to me like, well, why aren't there fossil fuels on Mars? Well, there's no dinosaurs on Mars. There's no plant life. So this is dead decomposing things from millions of years ago that under basically they decomposed at a rapid rate and then got put under heat and pressure. And so they created the fossil fuels. The first fossil fuel that we want to talk about is coal. It's a solid form. It's very prevalent in parts of Russia and China and in the United States. And we can talk about the different types of coal. The first type is not really a type of coal. It's called peat. It's partially decayed stuff. That you can kind of almost think about this as like cow patties, like hardened, dried out cow manure. That's very similar to peat in consistency. After that, we're going to get into lignite. So as we move across the as we move right across the screen, we're going to get more and more carbon, and they're going to generate more and more heat when they're burned. So lignite is brown coal, relatively low heat. We do not burn this for energy. After that, we have bituminous coal. This is used pretty much, this is what we burn in order to generate electricity, found in parts of the United States and in China. And then actually there's one that falls between bituminous and anthracite, and we call that subbituminous. And so it would be right here where the arrow is. So as you put these things under more and more heat and pressure, we're going to get the different types of coal. And so bituminous coal is the most cost effective. It does have a really high sulfur content, and so it's going to release a lot of SO2. You might want to make a note of that. SO2 coming from the burning of coal. And so we really like to see subbituminous. China probably burns a lot of bituminous, but the United States does not. Anthracite, it's not really super prevalent. It's pretty expensive, and so it's not really worth it to burn it for electricity because it's so compressed. And so we really burn bituminous in China, and then subbituminous, which is not on the screen, but kind of falls between bituminous and anthracite in the United States. Major downsides to coal. Coal is the least, the fossil fuel we like the least, okay? So if we look here, this graph. Oh, let's go back. This graph shows us probably the amount of CO2 that's released by the various fossil fuels. And we see that coal-fired electricity releases the most amount of carbon dioxide. So that's a major downside. So coal has some downside. It contains impurities, and those release into the air when we burn them. And so it causes major amounts of air pollution, including that SO2 and CO2. Additionally, it releases trace metals like mercury. Mercury is something that we're going to talk about next unit, and then as we get into pollution, but basically this mercury falls to the ground, gets into the water, gets into the fish, and it can cause, if people eat the fish, it can cause neurological disorders. The combustion of coal leads to increased levels of air pollution. That ash is left behind. We call that particulate matter. That can run off. Heavy amounts of carbon dioxide are released into the air. Also, in order to mine for the coal, massive, massive, massive amounts of habitat destruction. And so it's pretty bad. So coal is our least favorite option. The downsides far outweigh the upsides. The upside is it's pretty easy to get a hold of. You don't have to really refine it. It's cheap. It's easy to handle. We have a lot of it. High net energy yield. We can put some technology on coal-fired power plants in order to make them a little bit better. One example is that of a scrubber, which removes SO2. We could also talk about an electrostatic precipitator, which removes particulate matter. You might want to write those two things down. Scrubbers, which remove SO2, and electrostatic precipitators, which remove that ash, that particulate matter. But these are expensive, and you have to kind of deal with their byproducts. So if you look, the air goes in, and they basically use water molecules to attract the SO2, and so then you have to pull out those sulfur molecules. There is a cap on SO2, and we're going to talk more about that later on, but just know that we can add a scrubber. It's just kind of expensive, and it has to be done when the plant is created, which is kind of hard. We do have something called syn fuels. These are kind of when the coal is made into a liquid or a gas phase, and we can use them to replace oil and natural gas. This is hard to do, high amounts of CO2. This is not readily something that we want to do. The next fossil fuel that we want to talk a little bit about is oil. So all of the fossil fuels have the same advantages and the same disadvantages. So all of their because they're all relatively the same. They're just different states of matter of the same thing, right? Coal is a solid, oil is a liquid, natural gas is obviously a gas. So they're going to be pretty similar to one another. Petroleum is a byproduct of the oil. The crude oil is what comes up out of the ground, and then we refine it into petroleum. Oil, as well as natural gas, is found here in the type of rock that we call shale. And so you can see here in the different layers, we're going to drill down, we're going to collect the oil, and then usually sitting on top of the oil is natural gas that we're also going to utilize. So crude oil is what comes out of the ground. Once we refine it, we can call that petroleum. Many of the petroleum refineries are in the Gulf of Mexico, and so we see huge pipelines that pipe from various parts of the United States to the petroleum refineries that are in the Gulf of Mexico. And every year they shut down at various times. And so you might see a little spike in the oil prices in the spring as the petroleum refineries go offline to be cleaned and maintained and then back online. So again, like I was saying, very similar to coal. It releases sulfur, not nearly as much as coal, mercury, not as much. It can run off, it can spill. We'll talk more about that later. It does still release carbon dioxide into the atmosphere. Upsides: cleaner burning, high net energy. We can transport it. We know how to do that. The infrastructure is already in place. For coal, oil, and natural gas, we already have the infrastructure. We don't have to build anything, and that's a major plus. And petroleum is used in everything. Plastics are made out of petroleum. So if we say that we're going to wean ourselves off of fossil fuels, that means we're going to have to wean ourselves off of plastic, which is not super realistic. So maybe what's more realistic is to wean ourselves off of petroleum for transportation, but we're still going to need that product for plastics. And you've seen a move away from single-use plastic, away from plastic bags, or away from plastic bottles in an effort to help that. But petroleum is in everything. So we're really, when people say, oh, I'm going to get rid of petroleum, we really need to evaluate what that statement means. We would just want to say maybe not for transportation, and we can replace products, but it's never going to go away entirely. We get oil, like I was saying, from the shale rock. And so it is trapped in the layers, and then we drill down and we extract that. You do need to know that drilling is how we get out oil. Some of kind of like an alternative are what we call the tar sands. The tar sands are found in Alberta, Canada, which is our northernly neighbor, and it's exactly like it sounds. It's tar, it's oil mixed in with huge amounts of sand. So the first big problem of this is that we have to clear cut. So think about all the disadvantages associated with clear cutting. We have to clear cut the forest in order to gain access to them. They don't have a ton of energy, and you have to boil that tar sand. So it requires a lot of water in order to separate the sand from the oil. Once you separate them through a boiling or a distillation process, that oil then still needs to be refined. And so it's put into the pipelines and shipped down to the Gulf of Mexico. When we do this, it generates huge amounts of waste. What we see is that waste is held in large lagoons that can be seen from outer space. It emits a ton of pollutants. The advantage is that it comes from Canada. Canada likes us. We're friends. We're trading partners. So it allows us to be a little bit more energy, not dependent on the Middle East, but it's still not really a great option. The downsides far outweigh the upsides. Natural gas, on the other hand, is made out of methane. Natural gas is the best option of all of the fossil fuels. It's the cleanest burning. It releases, when I say it's cleanest burning, what I mean is it releases the least amount of CO2. Do not write clean burning on your papers, right? Releases the least amount of CO2. It produces half as much CO2 as coal. It has a pretty high net energy yield. It's cheap for us to utilize and for us to extract out. We have the existing infrastructure. It burns cleaner, so it's not going to release nearly as much sulfur. There's no particulate matter. However, there are some downsides to extracting it, including contaminating some aquifers that we'll talk about in another video. So again, here we've laid out the advantages and disadvantages. The major disadvantages is that methane can escape, and methane is a greenhouse gas. It's going to cause climate change. But we have to go looking for it, and there's some downsides to trying to figure out where those deposits are. On the upside, it has fewer impurities, doesn't release nearly as much carbon dioxide, so it's really a benefit. What we'd like to see is that we were mostly reliant on renewable resources, things like solar or wind has got some major disadvantages, but it's improving. And then we would supplement with natural gas, right? You can't use solar on days that aren't sunny. You can't use wind if the wind's not blowing, but natural gas could supplement our use of those. And it can be used in transportation. You can't really you can't drive your car with a solar panel. So that's why the fossil fuels, specifically coal and, I'm sorry, not coal, the fossil fuels such as oil and natural gas are so beneficial, because that's how we power all of our transportation. Don't write down that fossil fuels power all cars. Nobody puts coal in the back of their car to make them drive to school, but there are natural gas powered cars. And then we all know we put oil in our cars. So oil has a huge advantage, and that's how we have our transportation system built. But more and more things like electric cars are coming forward. Electric cars aren't really beneficial unless your grid is off fossil fuels. So if your grid comes from coal, that's not really any better. But if we could power our grid by solar or wind, then we could have electric cars. That would be the way to go. All right, so with this, I'm going to be done. I hope that this was beneficial. I know that I talked really fast. I'm just trying to make these videos a little bit shorter for you guys, but you can always pause, rewind, go back, and do what you need to do.